All right, we're going to do a little bit of a jump here, and we're going to go to the last section in Chapter 3, which in some respects really doesn't have a lot to do with the rest of the chapter, and it's fairly brief and compact, and so I thought we could do it here on top of what we've already done before we move into the rest of Chapter 3. Basically, this looks at two types of variation: direct variation and inverse variation. It's called direct variation basically when both items change in the same way. So, for instance, if y varies directly with x and y is 42 when x is 7, we want to find y when x is 13, we set up an equation that looks like this: y equals kx, or we can also set up, because k is just a constant, y over x equals k. And so this is why it's called direct, because basically if I double y, then I have to double x, whatever numbers they were, so that the k remains the same. If I cut y in half, then I have to cut x in half again to make the k be the same. So no matter what, I have to do the same thing to both x and y so that they always come back to the k. And so that's why it's called a direct variation. However, a different way, instead of writing out an equation like this, is I can set up a situation like this. Here, y1 over x1 equals y2 over x2. And I kind of think of the ones as being the before case. So up here, my y42 and my x7 would be the before case. And then the after case is, well, now what's y when the x is 13? And so that allows me to set it up in this form. So here's my y1 over x1 equals y2 over x2. Here's my 42 over 7 equals the new y over 13. I can then cross multiply, which basically means that I multiply these two, and then I multiply those two. So note the 42 times the 13 on the one side, the 7y2 on the other side. That's not a square, that's just a name, y2 versus y1. Go ahead and multiply and divide, and we find out that y2 in fact had to be 78 when x was 13. Another way of looking at it, of course, is that 42 over 7 is 6. 78 over 13 is also 6. In other words, the ratio equaled the same value. Now, a second way you could solve this problem is I could start off with my y equals kx, plug in the 42 and the 7, my initial values, and solve for what is k. And so it turns out k is 6. So now instead of thinking it in terms of y equals kx, the general form, I've got y equals 6x because k is 6. And then I could just go ahead, plug in the 13, 6 times 13, and there's my 78. And so I'm not really dealing with fractions. The only downside is I have to go and find k first before I can then use that to go and solve for another one. Now, that was direct variation. Inverse variation basically is where the numbers go in opposite directions. So if I double one, the other one has to get cut in half. If I go times 5 for one, the other one has to be divided by 5, because in this case, note that when I rearrange it in terms of k, it's the product of the two that has to equal the k. So if x is going up, then y has to go down in order for the same k to remain a constant. And that's why it's called inverse. One goes up and the other one goes down. In this case, I can rearrange to do my before and after as x1, y1 equals x2, y2. Now, honestly, whether it's the one that we just looked at, the y1 over x1 equals y2 over x2, or here, the x1, y1 equals the x2, y2, I kind of like this form better than the form that has the k in it, just because they're going to give me 3 of the 4 numbers. I plug in the 3 numbers. There's one to solve for. Just go ahead and solve. So in this particular case, we want to look at y is 10 when x is 8. Find y when x is 5. And so, again, here's my before and after case. X1, yn, so 8 and 10. 5 and the y2. 8 times 10, of course, is 80. Divide by the 5. It turns out that y2 has to be 16. Or I can go through it and figure out k first. So 10 equals k over 8, which means k had to be 80. And so now my equation becomes y equals 80 over x. Plug in the new x, and I find my new y. So there are 2 ways. I don't really care which way you want to use, whichever one is easier for you to manage. But this does give me 2 ways to do it. And as I said, the main purpose of this is to introduce you to direct variation, in which both x and y have to change the same way. In other words, double one, double the other. And inverse variation, in which they have to go in opposite directions. So if I double one, I have to cut the other one in half. All right, let's look at a couple of extra examples. So y varies directly as x. So when I read that, I know right away that I have this type of setup. If y is 78 when x is 6, find y when x is 15. So let's go ahead and first find the k. And so we're going to have 78k times 6. And so divide both sides by the 6. And that tells me that k is going to be 13. So now my equation is y equals 13x. Go ahead and plug in the 5. Y equals 13, or excuse me, the 15. And so y is 195. And so that's where this is doing it where I had to find k first. All right, now let's do it the other way. Or y1 over x1 equals y2 over x2. The before and after. So that'll lead me to 78 over 6 is going to be y2 over 15. And again, I can do the cross multiplying. That's going to give me, let's see, 78 times 15 equals 6y2. So y2 is going to equal 78 times 15 is 1170. Divide by the 6, and y2 equals 195. Same thing we got before. So you see that I'm off screen, so let me go ahead and move it over so that you can see everything. All right, second example. Y varies inversely as the square of x. So this is going to be k over x squared, the square of x, not just x. All right, and we got if y is 4 when x is 6, find y when x is 3. So 4, and we have 6. Make sure you do the square. So 4 times 36 will equal k, or k will equal 144. Then we now have 144 over x squared as our new equation. So x is going to be 3. And again, it's squared. And that's going to give us y equals 16. All right, let's do it the other way now. So x1 squared y1 is going to equal x2 squared y2. So 6 squared times 4 is to equal 3 squared times y2. And of course, that's going to give us 36 times 4 over 9 is y2. 3 squared is 9, so divide by that. 36 over 9, of course, is 4. 4 times 4 gives us our 16. All right, our last example, the height that a ball bounces varies directly as the height from which it is dropped. If a ball dropped from a height of 55 inches bounces 25 inches, how high will the ball bounce if it were dropped from a height of 88 inches? So, this is directly. So, y equals kx. We have 25, which is how high it bounced. 55, how high it was dropped from. So, k will equal 25 over 55, which is 5 over 11 if I reduce. So now my equation becomes 5 over 11 x, and then 5 over 11 times the 88, and of course 11 goes into 88 8 times, so y is 40. And really I should say that's my y2 is what I'm looking for. And so there's my answer. Note that I didn't turn the 5/11ths into a decimal just because it was easier to work with it being 5 over 11, and of course 11 went into the 88. And then, as before, if I'm doing direct, I can set it up as a before or after. So here 25 over 55 has to equal y2 over 88. Or y2 equals the 25 over 55 times 88. And of course I can cancel again. That's going to be 5. That's going to be 8. And then 5 of course goes with the 25. I'm left with 5 times 8. And so there's my same answer at the end. So inverse variation and direct variation, and some examples of each. And I'll tell you to finish up, the most common place to make a mistake besides did you do inverse versus direct is when it says square of something, you have to make sure and actually do the square. If you leave that part off, of course, you will get a wrong answer.